Hello guys, welcome back to the channel. Today we are discussing circular motion where we'll be discussing all those topics like banking of roads, uniform circular motion, vertical circular motion, conical pendulum and bending of a cyclist, taking a turn on circular road. Now, before moving on to those topics, we first of all need to understand what is centripetal force. We all know that centripetal force is the force acting towards center of the circle, but the question is it some specific type of force that it has a particular formula? Or there are multiple formulas to centripetal force? What is it actually? So, centripetal force is the force which keeps the object rotating in a circle. Now, for example, in the figure you can see here, the satellite is completing its motion around the earth and it's nearly a circle. So we can say that the gravitational force from the earth is making the satellite go in a uniform circle. The gravitational force from earth is making the satellite completes its circular path. So we can say gravitational force from the earth is acting as the centripetal force in this case. Alright, now let's take another case. This is a child. He is revolving the stone in a circular motion tied to a thread. Alright, now there must be tension in the thread and tension should be pointing towards the center of circle. Now in this case, tension is acting as the centripetal force. Remember, I mentioned centripetal force can be any force which is pointing towards center of circle. Now let's understand with one more example. As you can see, this is a photo of a child. He is revolving a stone in a circular motion and it is tied to a thread. So we know that tension must be pointing towards center of the circle. So in this case, since tension is pointing towards center of the circle, so we will say tension is the centripetal force in this case. Alright. So centripetal force is not a specific type of force. Any force can act as centripetal force as long as it is pointing towards center of the circle. Alright. So the resultant force acting towards center of circle is always centripetal force. Got it? So here I have written tension is acting as centripetal force. In the gravitational attraction from Earth towards the satellite, there the gravitational force is acting as the centripetal force. Alright, and many more examples can be there. Like if you see this example, you're taking a turn on a circular road, so the friction is now acting as centripetal force. If friction would not be there, your car would slip away out of the circle. So what is preventing it? Friction is preventing sliding. Means friction should be center of the circle, towards center of the circle. Alright. Now let's start with the definition. So what they have written here is that centripetal force is the force that keeps an object moving in a circular path. It acts towards center of the circle. For example, when you swing a ball on a string, the tension is acting as a centripetal force. The example which we discussed. Alright. Now there are some formulas which you need to remember. After that, we will start discussing the major cases. So what is centripetal force? It is the resultant force pointing towards center of the circle. What is its formula? F is equals to m times a. Now since you're talking about centripetal force, so centripetal acceleration should be there as well. And what is the formula for centripetal acceleration? It is v square over r, or it is also written sometimes as omega square r. What is the conversion? See, we know that v is equals to omega r. So v square by r can be written as omega r whole square by r, which becomes omega square r square by r cancels square, so omega square r. Both are the same thing. This will be given to you in your data booklet. Now, if you multiply any of these two with mass, you will get the centripetal force. So mv square by r or m omega square r. Alright, this is the formula that you need to remember, and I am repeating this again. It can be any kind of situation. It can be banking of road, vertical circular motion, horizontal circular motion, conical pendulum. You just need to remember the resultant force towards center of circle will be equals to mv square by r. Resultant force towards center of circle should be equal to mv square by r. Alright, now let's start with the first case. You're taking a turn on circular road, we know that friction is acting towards center of the circle. Is there any force acting outwards? I don't think so. If you observe the car standing from outside, you're not in the car. Observe it standing from outside, so you will not feel any force outwards. You will just think that there is a center force, which is friction. All right. So we can say friction is acting as the centripetal force. Now, what is the formula for friction? It is mu times normal, coefficient of friction times normal, and centripetal force is mv square by r. What is normal? Normal is equals to mg, and this is equal to mv square by r. So from m, you can cancel the other m. Mu g is equals to v square by r. You rearrange it, you will get v square is equals to mu rg. So v is coming out to be root mu rg. Now what is this velocity? This is the maximum velocity with which you can take a circular turn without sliding. So if your velocity is just a little bit more than this, then the car will slide out of the circle. Alright, and the concept is only this: friction is acting towards center of the circle, so friction is the centripetal force. Mu into normal is equals to mv square by r. Now, the second case, when you are whirling a stone tied to a string. So in this case, we know that tension is towards center of the circle. Is there any force outwards? I don't think so. So what is the resultant force towards center of the circle? It's tension only. And we know that resultant force towards center of circle is equals to mv square by r. So tension is equals to mv square by r. That's it. Or you can say tension is equals to m omega square, r should be here. So both these formulas can be applied. They can give you very simple questions on these, and you can just apply the formula and get the answer. This is one of the simplest cases. Alright. Now, one important case starts, and I just want you to remember the resultant force towards center of circle will be centripetal force. Alright. Now, in this conical pendulum, the setup is just like this. You have your thread. This is your thread, and you have your ball, let's say, and you're whirling it like this. Just try to visualize. You're whirling it like this. Alright. Now, in this, they can ask us the angle, they can ask us the tension. So, how do we do this? First of all, tension must be acting like this. Tension must be here. And if this is theta, so this should also be theta. Alternate angles. Now we do the components. We know that side adjacent to theta is cos theta. So the component of tension vertically will be t cos theta, and then perpendicular to it will be t sin theta. Now you can clearly see that this is pointing towards center of circle. So this should be equals to mv square by r. The same thing I have written here. T sin theta is equals to mv square by r, and t cos theta is equals to mg. Alright. Now you just need to solve this. Why am I saying t cos theta is equals to mg? See, t cos theta is pointing vertically upwards and mg is vertically downwards. Is there any motion up or down? I don't think so. So t cos theta should be equal to mg. Now when you divide the equations, or you can do substitution, you will get tan theta is equals to v square by rg. So your theta will be equals to tan inverse v square by rg. In some questions, they will give you all the values and they will ask you theta. In some questions, they will give you theta, r and g. They will ask you velocity. This is how you can do this. Now, I will repeat again. It might look a little bit complicated, but what you have to simply do is, tension is here. See, this is your tension. I have made a specific triangle for it. Then this is theta. So side adjacent to theta is cos theta. So this is t cos theta. And then its perpendicular will be t sin theta. So I've written t sin theta here, t cos theta here. T sin theta is acting towards center of circle, so t sin theta is equals to mv square by r. And t cos theta is balancing the weight, so t cos theta is equals to mg. Alright, I hope this is clear to all of you. Now let's move on to the next case, and this is one of the most important cases. See, this is vertical circular motion. Just imagine you have a thread tied to a stone and now you're whirling that stone in a vertical circle. Or you might have seen some people trying to do this experiment where they tie the bucket with a rope and there is little bit of water in the bucket, some water is there, and then they try to show you that even if I rotate this in a vertical circle, the water from the bucket will not fall down if they are doing it properly. If they are demonstrating it properly, the water in the bucket will not fall down. All right. Now let's study the physics behind this. So in our syllabus, mainly they ask us two cases. They ask us at the bottom, what is the condition at bottom and what is the condition at top. All right. Now, in order to understand this, so let's say at the bottom, weight will be acting downwards, mg, and the tension from your rope must be acting upwards, T. Now, remember the point. Resultant force towards center of circle is the centripetal force. So, resultant force should be T minus mg. Now, in case you're wondering why not mg minus T, see, if you're saying mg minus T, you're clearly telling me mg is greater than tension. But should it be greater than tension? I don't think so. If it is greater than tension, the rope will not be able to hold it. Apply some common sense here. If the tension is less than the weight, how will you be able to hold it? Right? This is why this is wrong and tension should be at least greater than mg. Alright? So this is the resultant force towards center of circle and we mentioned that resultant force towards center of circle should be equal to mv square by r. So at the bottom, your equation will be, I've written this here. It's written here. At the bottom, tension minus mg should be equals to mv square by r. Then you can say tension is equals to mv square by r plus mg. Now this is also telling you that when you try to hold something, it is most difficult when you're holding it perpendicularly downwards because tension is maximum there. Alright. Now what happens at the top? Now see, at the top, see, tension will be acting in this direction and now the weight will also be acting in this direction. So we can say tension is downwards and mg is also downwards. Is there any force outwards, out of the circle, perpendicularly upwards? I don't think so. Again, resultant force towards center of circle is the centripetal force. In this case, tension plus mg is pointing towards center of circle. So tension plus mg is equals to mv square by r. So at the top, tension plus mg is equals to mv square by r. Now, sometimes in our examinations, they ask us regarding the minimum velocity at top. Now, you just have to visualize a little bit that even if the tension becomes zero at top, you might have seen that it still completes a circle. Or I'll recommend you to try all of this. You can just take a wire tied to some stone or something and try to whirl it in a vertical circle. You will notice that even if the tension becomes zero at top, it still completes a circle. Alright. So for minimum velocity at the top of circle, take tension to be 0. So 0 plus mg is equals to mv square by r. Mg is equals to mv square by r. M cancel from m. V square is equals to rg. So v is equals to root rg. This is the minimum velocity at top. Means if you want to complete a vertical circular motion and you want to do it with minimum velocity, see, you can do it with maximum velocity, it's very easy. Revolving something at very high speed is very easy. But if you want to do it with minimum velocity, your velocity should be root rg. Not below this. If it is below this, then it will not complete a circle. Alright? So, now let's look at this figure. This figure is summarizing all the points for us. At the bottom, mg is downwards and tension is upwards. So what is the resultant force? Tension minus mg. Tension minus mg is equals to mv square by r. So tension is equals to mv square by r plus mg. They have written this in this form here. And at the top, tension is downwards, mg is also downwards. So what is the resultant force at top? Tension plus mg is equals to mv square by r. So tension is equals to mv square by r minus mg. Now you can see for yourself, I mentioned that at the bottom tension is more. It is mv square by r plus mg. And at the top tension is very less. mv square by r minus mg. Alright. These are the two cases which are asked in our examinations regularly. Now there are some questions. Let's try those. For example, this question is there. They're simply asking that what should be the minimum velocity at the top. There is a cart at the bottom, sorry. There is a cart of mass m enters a smooth vertical circle, alright. The cart just manages, now just think about it, just manages, what does it means? It simply means that it is the minimum condition. Now, how to solve this question? See, just now we did that at the top, minimum velocity should be rg, root rg, right? So, what I will do here is, I will apply energy conservation between point A and point B. We know the minimum velocity at point A, sorry. How much is it? Root rg. And we also know the height between A and B. What is the height difference? 2L. Alright. So what I've written here is, we need to find minimum velocity at bottom. We know that the minimum velocity at top is V is equals to root rg, or V square is equals to rg. Alright. Now let's apply energy conservation between top point and bottom point. Now see, at the top point, GPE should be there and kinetic energy should be there. GPE will be mgh, and what will be the height? Height will be 2r, twice the radius, or you can say diameter. This is diameter only, right? So mg into 2r substituted, half into m. What is the velocity at top? It is root rg. Root rg square will be directly rg. Alright. And do we have gravitational potential energy at the bottom? I don't think so. So we will only have kinetic energy at the bottom. So I've written kinetic energy at B point. That will be equals to half into m into Vb square. Now you just need to solve this equation and your answer will come out to be root 5 rg. So this is the minimum velocity one should have at the bottom in order to complete a vertical circle. Earlier we did it for top, it should be root rg, but at the bottom it should be root 5 rg in order to complete a full vertical circle. Alright, question is not difficult. What I have done here is just apply the energy conservation at point A and energy conservation at point B and equate them. At point A, we had gravitational potential energy plus kinetic energy. At point B, we had only kinetic energy. Alright, now let's try another question. Now, in this, it is something different than what we have studied. They're saying now it is at some angle and you have to tell the tension at this angle. We have just done the cases for top and bottom, but how to do this one? Now, just think about it. They're asking that they're telling you that this is 60 degrees and the object is somewhere here. Alright. Now just think about it. Mg should be downwards and this angle should be 60 degrees because this is 60. So it's just an extension of it. So this should be 60 as well. Now we know that the side adjacent to theta is the cos theta. So this will be mg cos 60. Now, if you understood this, then the question is done. Now just think about it. Tension is upwards towards center of circle and mg cos 60 is downwards. What did we discuss? We discussed that resultant force towards center of circle should be equal to mv square by r. Now, is tension the resultant force, or mg cos theta is the resultant force, or T minus mg cos theta is the resultant force? I think T minus mg cos theta is the resultant force. Right? It should be the sum of forces, smaller one subtracted from the larger one. Now, if you're thinking mg cos 60 should be larger, apply a little bit common sense. If this was if this was larger, the string would break, right? So tension should be greater than mg cos 60, and this should be equals to mv square by r. So we can say tension is equals to mv square by r plus mg cos 60. Now you just plug in the values, you will get the answer to be 8 newtons, which is B. This is nearly similar to the bottom case that we did. We did that mg is downwards, tension is upwards. So we did tension minus mg is equals to mv square by r. What's so different with this? Now it's only at an angle. So it will be tension minus mg cos 60 is equals to mv square by r. Alright. Another question, and you need a little bit of visualization from this. You might have seen those videos on YouTube where a person on his car or bike completes a full vertical loop. Now, in these kind of questions, tension is not there. There is no string tied to them. But is the concept similar? Yes, it is. See, now in these kind of situations, tension is not there, I agree. But in place of tension, the normal force should be there, because this person is in contact with the surface now. Alright, so if this was a tension question, then you would have written that, what is the equation that you wrote at top? We wrote that tension plus mg is equals to mv square by r. Now there is no rope here, it's just a person who is completing a vertical circle, so vertical loop. So in place of tension, it will just be normal plus mg is equals to mv square by r. Very simple case. Now this can be said for ball as well. Let's say there is a bowl and someone is going like this. So at this point, normal will be upwards, mg will be downwards. So you can say normal minus mg is equals to mv square by r. It's exactly the same case. It's just that in place of tension, now you will use the normal reaction force. Alright. Here tension was applied, but if tension is not there, if a rope is not there, then normal should be there, because the person is in contact with the surface now. Got it? Alright. Now let's do an exam style question based on the similar concept. Alright. Now let's erase this. Now let's read through the question first. A roller coaster car of mass m approximates, it is covering a circle, alright, nearly. Which expression gives the linear speed of the cart? Alright. Now you just need to visualize a little bit. First of all, where will the weight be acting? Weight should be downwards towards the center of circle. Alright. Normal force. Normal force in this case should be upwards, because it is up the slope. It is up the surface, not below the surface. This one is below the surface, so normal is downwards. This one is on top of the surface, normal is upwards. Now just think about it. Should mg be larger than normal, or normal should be larger than mg? With a little bit of common sense, we can say that mg should be larger than normal, because if it is not, if normal is larger than mg, then the ride will fly into the air, right? So mg should be greater than normal. So what should be the resultant force towards center of circle? Mg minus normal. And this is the resultant force towards center of circle. So this should also be equal to mv square by r. So I've done the same thing here. Mg minus normal is equals to mv square by r. Then we just need to do substitution. See, you transpose r to the other side, r gets multiplied. Then you transpose m to the denominator to the left. Then take square root, you will get the answer as d. Alright. Now, next question, and this is one of the good ones. Now see, what's the question saying? It's saying that there is a pendulum bob which has a speed 3 meters per second while passing through its lowest position. So at the bottom, speed is 3 meters per second. Got it? What is its speed when it makes an angle 60 degree with a vertical? So 60 degree angle I have made with the vertical, and at this point, let me use a black marker. So at this point, we need to find the speed. Alright, so how to do this? The simplest way to do this question is using energy conservation. What I will be doing here is that I will take this as point A, the one with the 60-degree angle, and the bottom point as point B. And we will apply mechanical energy conservation between point A and point B. So what I've written here is that GPE plus kinetic energy at point A is equals to GPE plus kinetic energy at point B. Very simple. Let's say this you understood. Now, what will be the GPE at point A? It should be mg times the height. Now, this is the only tricky part which might be problematic for a few students, because you need to find the height difference between A and B. You need to know this. Alright? And we are only given with the length. So now this will need a little bit of maths. Focus on the screen. See, you know that this is L, right? And you also know that this total length should be L as well. Now, what I'll do here is I'll take the component adjacent to it. So I'm taking this component. See, if this is L and this is theta, this small section should be L cos 60, right? It's just a triangle. If this is 60 and this is L, there should be L cos 60, right? Now, just think about it. You know the total length is L, and you know this section is L cos 60. You need to find the other section, this one. This is the one you need to find. So what will be this? This will be L minus L cos 60, right? You are given that this is total L and you need to find this section. So what does the math say? L minus L cos 60. This should be the height, right? So in place of height, I have substituted L minus L cos 60. What is the kinetic energy at point A? We are not aware. That is what we are trying to find out. So I have just written it as half into m into VA square, keeping it as a variable. And is there any gravitational potential energy at point B? Point B is at the bottom, so I don't think there is. Let's take it as 0. And kinetic energy at point B, yes there is. They have told you in the question 3 meters per second. So half into mass into velocity square will be 3 square. Now you will just have to solve this value. I have not solved it. You can just put it in the calculator, you'll get the answer. I hope you're getting the concept. We just needed to find the height between point A and B, and for that we have used a little bit of maths using trigonometry. We know that this is L, so this should be L cos 60 and the total length is L. So the remaining section, if you want to find out, it will be L minus L cos 60. Then it's just basic physics with energy conservation. Alright? Now, let's start with the banking of roads case. Now, this photo I have attached here for you to visualize that roads are banked like this. They're always lifted at some angle to prevent sliding, especially in case of high-speed cars. Alright? Now, how does it help? See, and what is the physics behind it? So, they're always banked at some angle with respect to the horizontal. Now, a better picture is this. So, this should have been the road, but now they have banked it. They have lifted it, inclined it at some angle theta. Now, we need to understand how does it help? How is it different than the normal road? Alright? On the normal road, we notice that when you're taking a circular turn, only friction helps you. Right? We studied this here that when you take a turn on a normal horizontal circular road, friction helps you to maintain your circular motion. But so what's different between the normal horizontal road and this banked road? Let's try to understand. For this, you need to understand the maths behind it. First of all, let's try to draw this, what I've drawn here, and let's try to replicate it here. See. So we know that mass should be downwards, so the weight should be acting downwards, mg. And this angle is theta. Alright. Now if you extend this a little bit, this should be theta as well. Why? Because this is 90 minus theta. Just visualize that this should be 90 degrees. So that should be 90 minus theta. Means this will be theta again. Now this is mg cos theta. And so this should be mg sin theta. The perpendicular component of it, right? Mg sin theta should be down the slope. So this should be mg sin theta. Now The normal force should be perpendicular to the slope, so this should be the normal force, and this should be theta as well, vertically opposite angles. So this is n cos theta, and perpendicular to it should be n sin theta. Alright. Now we are just missing one important point, which is friction. Now just think about it. Your car is going like this, and you want it to not slide away. And where will it slide away in case it does? Out of the circle, here, right? So in order to prevent this, friction should be acting where? Down the slope. Think about it. You want the car to not to slide away out of the circle. What is its tendency? It might slide away like this, right? So in order to prevent this, friction should be acting in the opposite direction, here. So friction will also be down the slope. Then you can focus here. See, friction is down the slope, and this angle will also be theta. So f cos theta should also be there, and f sin theta then will be perpendicularly downwards. Alright. Now this is the difference. In the normal horizontal circular motion, we were noticing only mg was downwards and friction was towards the center of circle. But in this case, friction is towards center of the circle, as well as normal sine theta is always also towards center of circle. And mg sine theta was downwards earlier in normal horizontal circular motion, but here friction's component is also helping you to stay on the ground. Earlier this was the case, now this is the case. So the forces are more now, it is helping you more. Alright. And what kind of questions they can ask you exams? The maximum they can ask you is that you need to just establish the horizontal equilibrium and vertical equilibrium. Now see, f cos theta and n sin theta, they're pointing towards center of circle, right? So f cos theta plus n sin theta is equals to mv square by r. And n cos theta should be balanced by mg plus f sin theta. So I've written this here. They can give you the values and they can ask you to find any one of the variables. That's it. Alright. The maths might be a little bit complicated for you in this, but just think about it. Mg is here, this is theta, so this will be mg cos theta. Normal is here, this is theta, so this will be n cos theta, this will be n sin theta. Then friction is down the slope, this is theta, so this should be f cos theta, and downward should be f sin theta. And these are the two equations which you need to remember. Alright, now our favorite case, bending of a cyclist or a rider on a road. You have always seen this when you are watching the MotoGP, let's say. When they are taking a sharp circular turn and they're at very high speed, they will have to bend. If they do not bend, the bike will go out of the circle and accidents will happen, which we never want to happen. Alright? Now, bending of a cyclist, see. Now, just think about it. With the vertical, the angle we are using is theta. Let's say the person is bending at some angle theta. Alright. Now, the person and the bike is in contact with the ground, so we can say normal should be something like this. Right. Now, if this is theta, let me use the white marker. If this is theta, so this should be n cos theta. The side adjacent to theta is n cos theta. Then the perpendicular one should be n sin theta. Now you can tell me yourself which force is acting towards center of circle. Is it n cos theta or n sin theta? N cos theta or n sin theta? Yes. N sin theta is pointing towards center of circle. Now it's just basic maths. N sin theta is equals to mv square by r. And n cos theta should be balancing mg, right? So m cos theta is equals to mg. Then you just solve it. You'll get the same formula again. Alright, this is the same formula as you're getting in the conical pendulum. Because just think about it, in conical pendulum as well, there was some force like this, some angle like this. Right? Just see. It's nearly the same case. There's a force like this at some angle. The results are a bit different, but the physics is same behind both of them. So normal is acting like this, n cos theta is here, n sin theta is here, n sin theta is acting as the centripetal force. So we did n sin theta is equals to mv square by r, and n cos theta is equals to mg. Divide them, you will get tan theta is equals to v square by rg, which means theta is equals to tan inverse v square by rg. Right. Now we have to discuss the kinematics of circular motion, and I'll be keeping it quick. So you can play the video on 0.75x. See, first of all, we need to understand linear variables and rotational or circular variables. See, in linear motions that we have been studying since last 2-3 years, we used to say that V is final velocity, U is initial velocity, A is acceleration, T is time, S is displacement. Now, the representation will be a bit different in the rotational or circular motion. Final velocity will be called as angular final velocity, and the symbol will be omega. For velocity, symbol will be omega in circular or rotational motion. So in place of V, omega final; in place of U, omega initial or omega naught. Acceleration will be called as alpha. This is alpha. Time stays the same. And displacement is S in normal conditions. The unit is meters, but here the displacement will be angular displacement, and this is the theta. Alright, what is the difference between displacement and theta? I'll give you one example. Let's say there is point A, there is point B. Both are 500 meters apart. And let's say two people are racing. This is your best friend and this is your second best friend. And you're sitting in between, away from both of them. You have a vision that covers complete track. Alright. Now, both of them are racing for 500 meters. So the displacement they will be covering is 500 meter. But just think about it. You're standing here. Your neck will be first of all facing both of them. Right. Now, as they are moving forward, your neck will be rotating. So the angle with which your neck is rotating is that angular displacement. It's just an example to give you a real life sense of it, what it means. The linear displacement is 500, but in order to watch this linear displacement, you had to rotate your neck from point A to point B. So the angle that you rotated it, let's say 60 degrees, this is the angular displacement. Alright. Now, equations of motion, the normal one is V is equals to U plus AT, V square is equals to U square plus 2A, S is equals to UT plus half AT square, S is equals to U plus V by 2 into T. Now, if you translate this or convert this into rotational equilibrium, rotational equivalent, so that will be omega final is equals to omega initial plus alpha into T. Omega final square is equals to omega initial square plus 2 into alpha into theta. It's just that alpha, in place of acceleration, I'm writing alpha, in place of displacement, I'm writing theta. Nothing different. It's just the variables. In place of S, you will write theta. In place of U, you will write omega initial, and time plus half into acceleration should be alpha. And the same thing is written here. Alright? It's just a conversion of variables. Now, some important formulas. Theta, as you have studied in maths as well, is equals to length of arc upon the radius. Alright? Or you can say theta is equals to length of the circular arc divided by the distance covered. And what is theta? It is angular displacement. What is angular displacement's unit? Unit is degrees or radians. Majority of the times in your questions, they will give you in radians. So just make sure to convert radians into degrees if you're doing any other calculations. Alright. So radians into 180 by pi is degrees. And also take a note of your calculator. Sometimes your calculator is in degrees and you're doing calculation for radians. So it creates an error there. You will get the wrong answer. So radians into 180 by pi should be degrees. And sometimes in questions they ask you that give me the answer in degrees and you have the answer in radians. So just do radians into 180 by pi is equals to degrees. Alright. Now these formulas are nearly the same. See, you know that velocity is equals to displacement over time. So here angular velocity will be equals to angular displacement over time. What's different in this? The unit for speed used to be, speed or velocity used to be meters per second. Here it will be radians per second. The SI unit is radians per second. Acceleration is change in velocity over change in time, and the unit you used to say is meters per second square. Angular acceleration will be change in angular velocity over time. The unit will be radians per second square. The conversions are similar. In place of displacement, you're using angular displacement. So the unit of meter changes to radians. In velocity, it is meters per second. Now it will be radians per second. In acceleration, it is meters per second square. Now it will be radians per second square. All right. And you're saying that theta is equals to length of arc by radius or distance. If you transpose it, theta into radius is equals to length, divide both by time, and you will notice that angular displacement over time is angular velocity into radius. What is the distance over time, length over time? What is it? Linear velocity. So we get the relation here, v is equals to omega r. This relation will be given in your data booklet. Next, you know that v is equals to omega into r, divide both by time again. So what is linear velocity over time? I think it is linear acceleration. What is angular velocity over time? I think it is angular acceleration into r. This formula is also given there in a data booklet. Alright, these are all the relations. One more thing, angular velocity's unit is radians per second. Sometimes in the questions they will mention it like this, 20 rpm. What is rpm? Rpm is revolutions per minute. So if you want to convert 20 rpm to radians per second, just multiply it by 2 pi by 60, because in one revolution 2 pi angle is there and minute is 60 seconds. So I've written the conversion here that multiply rpm with 2 pi by 60 to get radians per second. Alright, this is all about. There is one more type of question that we need to discuss. It's questions like these. See, now this is a rotor and amusement park. You need to try to visualize a little bit. See, just think about it. If the person is here and the person is not going down or up, right? The person is not going down or up, but just think about it, the weight of the person must be acting downwards, right? Now try to visualize, if the weight of the person is going downwards, acting downwards, but why is the person still not going down, not moving down? The reason might be that friction is acting at the top. I'll again ask you to try to visualize a little bit. If the weight is downwards, why is the person not going down? Because there might be a force acting at upwards. And what is the force acting upwards? Friction should be there, right? So in these kind of questions, you just need to label that friction is the force above, mg is downwards, and this is the normal reaction force. Because normal is always perpendicular to the surface, and now the surface is vertical, so normal should be horizontal, right? And then in this case, you know that normal is pointing towards center of circle, right? Towards center of circle, normal is pointing. So now you will say normal is equals to mv square by r, and friction is equals to mg. What is the formula for friction? Mu into normal is equals to mg. Now what is normal? Normal is equals to mv square by r. So m cancelled from m, v square is equals to rg over mu. Alright, so do not try to remember or memorize this, that normal should be equals to mg, and on inclined plane normal should be equals to mg cos theta. Normal can be anything. In this case, normal is acting as the mv square by r centripetal force. Alright, on a ground horizontal surface, normal is equals to mg. On an inclined plane, normal is equals to mg cos theta. But in a setup like this, normal is acting as the centripetal force. Alright, so also keep this in mind. Now, we are done with the complete syllabus of circular motion. In case of any doubts, feel free to let me know.